Okay, so today we're going to look at 5.5 on linearization, also known as our tangent line approximation. Okay, so before we get started with the notes, I just want to look at, in general, what does this linearization mean? So if you take a graph, okay, and it can be any kind of graph. Let's say it's a square root function, okay, which we'll look at later. Okay, and we can find the equation for the tangent line at any point, right? What do we need in order to find a tangent line? We need a point and we need a slope, right? Okay, so how would we find that? Well, again, given a point, so let's say, for example, I give you, let's say I give you the point 4, right? And that will be 4, 2. I know my graph isn't quite drawn to scale here, so I have a point. And then how would I find the slope of that line? Well, remember, the slope is just another word for derivative, right? So I could do y prime, and that would be 1/2 x to the negative 1/2, or 1 over 2 root x. Okay, and then I could figure out, well, what's y prime of 4, right? So I do plug in the 4, and I would get 1/4. So this line would be, okay, here's my point 4, 2. And my slope right here is 1/4. So I could come up with the equation for that line. It would be y minus 2 equals 1/4 times x minus 4. Or what we're going to see today, I'm going to add the 2 to the other side. Right? So there's this equation of this line. Now, what we're going to look at today is, why is that tangent line useful? Well, it's useful when we want to evaluate points that are really close to that point of tangency. So for example, if I want to approximate, well, what happens here when x equals 3? Well, I can actually take that and plug it in here and see what happens. So I can plug it right into the tangent line, and we're going to get an approximate y value. Okay, so for example, I would have 2 plus 1/4, so when x is 3, right? So I would have 2, and then that will be a minus 1/4, or 1 3/4. So that means my square root, in other words, what I'm saying is, to approximate the square root of 3, I can use the tangent line at 4 to approximate it. And actually, if I do that, I get 1.44. Now, again, square root of 3 actually comes out to 1.44. So it's not that close, 1.75. But what we'll notice is, if we get points that are even closer and closer to this point of tangency, we're going to get more and more accuracy. Okay, so let's take a look at the notes now. Okay, so how does this work? Well, first of all, we need to have a differentiable function, which means it has to be continuous, and it cannot have a corner cusp or a vertical tangent. So we have this L of x, meaning our linearization. It says f of a plus f prime of a times x minus a. Well, this is just point slope form. Okay, and so we have it underneath here written y equals y1 plus m times x minus x1. So imagine, right, our f of a, that's our y1, our f prime of a, that's our slope, and then x minus a, that's our x minus x1. Okay, so again, we have a point, our slope is dy dx, so we can find the equation of that tangent line, again, to find an approximation that is close to that, okay? All right, so example 1, we're going to break that up into 2 parts. Find the linearization. Again, that's just a fancy word for tangent line. So part of this lesson is not new. Finding the equation of the tangent line, we've been doing that for the last several chapters. It's this aspect of approximating that's going to be new. Okay, so let's start. So it says find the linearization, that's part A. Part B is going to be use that tangent line to approximate f of a plus 0.1. And then how accurate is the approximation to the actual value? Okay, so let's start with A. Again, what do we need in order to write a tangent line? We need a point and we need a slope. Okay, well, we need a point. So we consider this as an x value here. Okay, so I have the x value is -4. So I can plug -4 in. So that'll be 16 plus 9. So we'll get square root of 25, which is 5. Okay, so we have -4, 5. We have our point. Now let's find the slope. Okay, so remember this is going to be x squared plus 9 to the 1/2. So we're going to have to use chain rule. So we're going to move the 1/2 to the front. X squared plus 9 to the -1/2 times 2x. Okay, so f prime, what do we notice? Well, the 1/2 and the 2 will cancel. I'll have x over square root of x squared plus 9. Now I want to actually evaluate, so I'm going to plug -4 in. So I'll get -4 over -4 squared, 16 plus 9, square root of 25 is 5. Okay, so now I'm going to rewrite that in my linearization form. Now you can also write this as the y equals. So if I'm thinking y equals, so here, y equals 5 minus 4/5, excuse me, times x minus -4, or x plus 4. In our linearization format, it will be L of x equals 5 minus 4/5 times x plus 4. Okay, so now B says find an approximation for f of a plus 0.1. So that means I'm finding f of -3.9. So we're going to approximate. We're going to get 5 minus 4/5, and then -0.39 plus 4. Okay, so that's going to give us 1/10. Looks like I should have given you a little bit more room. And that's going to give us 5 minus 2/25, which equals 4 and 23/25. Okay, so 4 and 23/25 is, oops, I typed that in wrong, sorry. 4 plus 23/25 is about 4.92. Okay, now the last part is how accurate is our approximation to the actual value. So in other words, how does, and again, sorry, I should have given you a little bit more space here. How does that compare to f of -3.9? So in other words, if I actually plug it back in to here, the original equation, let's see what we get. So I have the square root of -3.9 squared plus 9, oops, I get 4.920366. That is pretty close. So using this tangent line approximation will get us within very high accuracy. So we got here 4.920366. So within actually the 10,000th, that's how close that we got to that value. Okay, let's try the next one with natural log. Okay, so the first step, again, for part A, I want you to find the tangent line. So again, we need a point and we need a slope. So we're going to plug in f of 0. So that's going to be natural log of 1, which is going to give us 0. So now we know the point is 0, 0. And now we want to do the derivative. So the derivative of natural log is going to be 1 over x plus 1. And so when I plug in 0, I get 1. So my linearization is going to be my value of f of a, so that's going to be 0, plus my slope times x minus my value of a, which was 0. Oops. That's supposed to be 0. So L of x is going to be x. Okay, now I want to see how close that will be to 0 plus 0.1. Okay, so 0.1 is going to be, well, if I'm just plugging it into there, I'm going to get 0.1. Now let's compare. And actually, I'm sorry, I should have labeled those as L. I want to compare to the actual, which is natural log of 1.1. Let's see what we get. Natural log 1.1, we get 0.0953. Which again, compared to what we got for our approximation, is relatively close. Okay, now we're going to approximate the root by using a linearization centered at an appropriate nearby number. Okay, so now I'm just giving you square root of 80. So the first thing we want to do is we want to come up with, what are we taking here? We're taking the square root. So I'm going to let f of x equal the square root of x. Okay, now it says I'm going to basically figure out, I want to approximate what the square root of 80 is. Now, what we want to think about, a nearby number. What square root do we know that is really close to 80? We know the square root of 81, right? So we are going to also let a equals 81. So using this information, let's see if you can come up with a tangent line. Okay, so go ahead and see if you want to pause it here and see if you can come up with the tangent line. So we have f of 81, so the square root of 81 is 9. Okay, so my point is 81 comma 9. And now let's do the derivative to find the slope. So I'll have 1/2 x to the negative 1/2, or 1 over 2 root x. So when I evaluate f prime of 81, I have 1 over 2 root 81, which will be 1 over 18. So my tangent line approximation is going to be, so again, where are we getting these values? So we're going to take f of a, so that was 9, plus the slope. So it's like y1 plus m, and then x minus x1. So again, just if you're having trouble with the formula, just keep in mind it's really just slope or point slope form, right? Where the x1, y1 is the point, and your m is the dy dx, your slope. So x minus, and then what was our value of a? It was 81. X, what are we plugging in for x? That's our 80. That's what we're plugging in here. Okay, so we get 9 plus 1/18 times -1, so 9 minus 1/18. And again, this would be a no calculator type of question, so I want you to think in terms of just leaving it in fraction form. And I know we don't normally write mixed numbers, but for here it's totally fine. So we can leave it as 8 and 17/18. Now again, let me minimize this a little bit. Okay, so we can actually compare 8 and 17/18 is 8.944 repeating. And let's see what happens when I plug in square root of 80. 8.944272. So linearization or tangent line approximation is a really great way to approximating things without a calculator. Notice we have it to the thousandth place. So this is going to be a really important topic, and actually leading into Calc BC, this shows up again. So it's really important. We'll see it many different places on the AP exam. But just remember, when you see that word linearization, it's just point slope form and approximating. Okay, next one, we have cube root of 26. Okay, so now I'm going to let f of x equal the cube root of x. Okay, so cube root of 26. So we want to think about what cube is really close to 26. It's 27, right? We can find that. So let's see, f of 27 would be cube root of 27, which is 3. So now I have my ordered pairs, 27, 3. And next we want to find the derivative, so we can find the slope. So it's going to be 1/3 x to the -2/3, or 1/3 cube root of x squared. Let's plug in 27. So I have 1/3 cube root of 27 squared. Well, cube root of 27 is 3. Squared is 9 times 3, 27. Okay, so L of x, or L of, what are we approximating? 26 is going to be, so we have f of a, which was 3, plus f prime of a, which was our slope, and then x minus a. What's our x? It's 26 minus 27. So we have 3 plus 1/27 times -1. So 3 minus 1/27 is 2 and 26/27. And again, you can plug it into your calculator to kind of see how close that's going to be to the actual value, and it's really close. Okay, last one, example number 3. Okay, so we have f of 2 equals -6 and f prime of 2 equals 3. Use a tangent line to approximate f of 2.1. Okay, so what do we need? We need This has all the information in order to write our tangent line, right? So what is our tangent line? And again, if this is getting a little confusing, just you can write it out the way we're used to writing it. Okay, so for example, if we're used to writing y minus y1, so y minus -6 would be plus 6 equals our slope, which is 3, and then x minus 2, that's fine. You can leave it like that. Just remember what we're substituting in for. So when I'm looking at my tangent line, right, y equals -6 plus 3 times x minus 2, what am I approximating? I'm approximating the value for x. So if I'm finding y of 2.1, it's -6 plus 3 times 2.1 minus 2. So it's going to be -6 plus 3 times 0.1. And again, I want you to be able to do this without a calculator, right? So these, you're not going to have too difficult of computation for these like on the test. So this is just going to be plus 0.3, and that's going to be -5.7.